Hi guys, in this video I'll provide an introduction to interfaces in Java. I start out by explaining the concept and then I'll provide a hands-on example. Let's start out with the concept. What is an interface? In Java, an interface is an abstract type that optionally defines a set of abstract methods. Now, optionally means that an interface may not define any abstract methods at all. It could be just an empty interface. On the other hand, an interface may define as many abstract methods as are needed. So it can have 0 to n abstract methods. Also, we cannot instantiate an interface. That means we cannot create any object of an interface type. Now, how are interfaces used? An interface is implemented by a class, or it can be implemented by multiple classes. Any class that implements an interface must define all methods that are defined in an interface. Now, how can a class that implements an interface define the methods? There are two ways. One is the class can implement all methods, or even just a subset in theory, or the class may be abstract. Now, if the class is abstract, it may not implement the methods at all, or it may implement a subset of the methods. For example, if we have an interface named A that has two methods, and now we have a class that implements the interface A, that class can either implement both of these methods in the interface A, or the class may be defined as abstract, in which case it does not need to provide an implementation for the methods. And last but not least, a class may implement multiple interfaces. That is different to class-based inheritance. In my other video where I explain inheritance, I show that a class can only inherit from a single other class. Whereas with interface-based inheritance, a class may implement multiple interfaces. Now let's take a closer look. In Java, an interface is defined using the interface keyword followed by an identifier. The identifier represents the interface name. In this case, I chose my interface name to be named simply A. Now, I could just leave it empty. In this case, I just have the type defined that does not have any abstract methods. But here I choose to add an abstract method named method A. This one is abstract. It does not provide any implementation, so I end the method signature with a semicolon. I add a second abstract method that returns an integer and is named getValue. Now, I mentioned that in an interface, all methods are abstract. And so we can leave out the abstract keyword. In this case, abstract is implied. It's still an abstract method. The same works for the public keyword. I can leave public out, and this method getValue is still public and it's still abstract. So here I have two methods, both of them are public and both of them are abstract, but for getValue, both of these properties are implied. Now let's see how we can use this interface A. I create a class named firstClass, and I want this class to implement the interface. So I add the implements keyword followed by the interface name. Now I get a compile error. The reason for this is that this class must define all the methods that the interface has. One way to do this is defining the class as abstract. So in this case, it just has two abstract methods that are defined in the interface. Optionally, it could also define maybe one or all of the methods even and implement them. So public int getValue, let's say this class implements the getValue method. And as a good habit, I add the @override annotation. This tells the compiler that I intend to override an existing method, that I provide an implementation for a method that is defined in the interface. Now, if my class is not abstract, I have to provide an implementation for all the methods that are defined in the interface. So here I'll add an implementation for method A as well. And I just output a message. So this should give you an idea what interfaces are and how we can use interfaces in Java. Let's take a look with a hands-on example. I close this and I create an interface named device. For a device, I'll define an abstract method named charge. So I want my program to handle devices, and I know that any device can be charged, but the way it is charged, it depends on the individual device. Now I create a class named laptop. I want this laptop to implement the interface. So I add the implements keyword. And inside this class, I implement the method charge. Here I simply output a message, charging laptop. Now I want to add a second class named cellphone. This class I also want to implement the interface device. And same as with laptop, it's a concrete class, so it's not abstract. So I provide an implementation for the charge method. In this case, I output the message charging cell phone. So to recap, I have an interface named device. This has a single public abstract method. Remember that public and abstract are optional, so I can leave these out if I want to. And then I have two classes, laptop and cell phone. Both of these implement the interface, and both of them provide an implementation for the abstract method in the interface. Now in my program, I can define a variable of the interface type. Let's call this device1. And I initialize it to a new object of laptop. Then I create a second variable, device2, and I reference an object of type cellphone. Now what you can see, using polymorphism, I can use the interface now to create variables and then just operate on the variables and on the interface type without actually knowing the exact concrete object that it is being referenced. Now here I create an array of interfaces, and this interface I name devices, and I initialize it to size 2. And the first device I initialize to device1, and the second device I initialize to device 2. Now this array holds two elements. First element is device1, second element is device2. The first one references the laptop and the second one the cell phone. And then I use a for each loop. For every device in my devices array, I want the device to be charged. So I call device.charge. Note that my entire program, except for the initialization, works on the interface type. It only knows that when I have an interface, the object that is being referenced definitely has a definition and an implementation for the charge method. So I can call charge without knowing the actual implementation. So when I run this program, on the output, I get two messages. For the first message, it's showing that it's charging a laptop. For the second message, it's showing that it's charging a cell phone. Now, a last word on interfaces and abstract classes. An interface is essentially an abstract class with only abstract methods. But there's a key difference between a complete abstract class and an interface. When we talk about inheritance, a class that implements an abstract class cannot implement any other class because we have single class inheritance. However, a class that implements an interface may implement other interfaces and may inherit from another class. So when you have the option between an abstract class and an interface, always prefer the interface over an abstract class. If the type needs to provide some implementations, sometimes an abstract class is justifiable and is preferable, but in general, always prefer an interface over abstract class. I hope you enjoyed this video. Thank you for watching.